All right, and the final piece in all this is vegetation type. That one is the most complex. That's why it's here at the end. So we have the same image composites, but we also include topography, elevation, slope, aspect, and gradients, climate gradients. So precipitation, and then average, minimum, and maximum temperature. So that's really important for separating different ecological systems that occur in specific locations. North slope versus south. It's going to require certain level of moisture and temp range throughout the year to support specific species. So that's why we include those there. They don't necessarily always help with cover and height modeling, but they might, as those models continue to get more sophisticated and develop. So then we have our training samples, and that is going to be based on field plots, and we label those field plots to an ecological systems category based on the species there or other information tied to it that we can label with expert opinion. So this is a really highly technical and important step. We have hundreds of ecological systems, so identifying which one these plots fall into is not always clear, and we have to do it often in an automated way because we're dealing with tens of thousands of plots. So it's a monumental task, and but we get it done, and we do a pretty good job doing it. We get support from NatureServe to with their regional experts to help with that, because no one person has all the knowledge needed to do this step. So same thing, we extract all of those layers and associate those to our training samples, build our machine learning model. This is similar to Lifeform. It's a classification, it's categorical data. And we get a lot of different models out of this because we have to separate out the different types and bring them together in the end. So we start, our bases, we pull out all the non-riparian, non-alpine types and model them together with according to dominant life form. And then we take all the riparian or wetland types and model them together according to their dominant life form. And we do the same for alpine types. And then we have barren and sparse types as well that we have to model together in a separate model. And then it seems like every geography has a handful of difficult types that just don't behave in this sort of standard process that we have to break out and handle separately. And again, that all gets merged through that same life form mask. So now we have one layer for each of these different sort of categories of, or I guess groups of ecological systems. And then those get sent through a few different masks. So where do we put the riparian types? Well, we put them where the riparian mask says they go. And that riparian mask is created through a separate modeling process to identify wetland and riparian areas. We have that same barren and sparse mask that we saw before is used to constrain where our barren sparse ecological systems fall. We have an alpine mask that was created to zone in on the alpine zone, and that's used for our alpine types. And then for the difficult types, they often have specific soils, or maybe there's a different layer out there that's helpful for constraining where that type occurs. And so that's all put together into our final model type layer. And then in the same way, we bring in all those non-vegetation types to create our final EVT map. So that's it for the crazy graphics. I have one final slide here just to show where we're at in evolution of LANDFIRE and how we're creating these vegetation products. So LANDFIRE started with 2001 base map, and that used this process, machine learning, to create those maps, and that was updated to account for disturbances in subsequent biannual updates using rule sets until 2016. This machine learning vegetation modeling process was used again to remap all pixels. And the following two updates use that same rule sets process, but then we wanted to try to incorporate some of this modeling into an update process. And we did that for LF 2023, where we generated these models according to 2023 imagery and brought that through in pixels that were disturbed in the last 20 years as a way to get things trued up for current ground conditions where there's so much change that it's difficult to get it accurate with rule sets. And then now for LF 2024, we're using that same rule sets process, and then we'll see where we go from there. But I guess the final piece of this is that this is being used to create our fuels products. So that's the important connection there at the end we don't want to forget about.